Welcome back to Zero Dark Emissions. In this episode, we'll be taking the chassis down to just about every single part so that we can get it all cleaned up and ready for repainting. Most rebuilds that I see just go down to the basic fixed chassis, but I really wanted to be able to clean into all of the nooks and crannies and prime all of the surfaces of each piece before reassembling, so we're taking it all the way down. We'll start with removing the steering gearbox, which was kept on to this point in order to help steer and jockey the rolling chassis into position in the garage. By the way, I will be keeping this. Even though there will no longer be power assist from the engine, I'll cap the hydraulic line ports, and this will still serve to transfer the steering column to the pitman arm and steering link, and then there will be a separate electrical assist unit added between the steering gearbox and the steering column. Next, we'll remove the body mounts. Now we'll remove all of the other fixed chassis components at the rear end. Up at the front now, this is the front radiator mount. I don't think that I will be reusing this. My radiator for the EV setup will be smaller, and I'll probably be mounting it in a different way. By the way, when I get to reassembly, I'll first be painting and reassembling all of the fixed chassis components, and then assembling all of the quote-unquote moving components later. And when I reassemble the fixed chassis, I'll be reusing the existing bolts and nuts, as long as they're in good shape, and they will be painted with the overall assembled chassis. But all of the hardware for the suspension components and whatnot, that will be all new hardware, which will be zinc-plated grade 8 hardware that will not be painted. Now that we have all of the basic low-hanging fruit, we can go ahead and get this up on jack stands. Now with the wheels off, we can get to the geared hub drain plugs and remove the gear oil in the geared hubs. These are the 6 bolts that attach the half shafts to the output flanges at the differentials. In order to keep the half shaft from rotating while I'm turning the bolts, I placed a square drive into the plug over the bolt that keeps the half shaft attached to the geared hub side. Once I get the ones that are accessible from the top, I'm turning the half shaft and replacing the square drive to keep it from spinning. This way I can get all of the bolts where it is easy at the top instead of crawling around at the bottom. Now that same plug can be removed, as well as the bolt connecting the half shaft, which will allow the half shaft to be removed. Now we'll get the nuts off of the upper shock bolts and then compress the springs so that the bolts can be removed. For the method that I'm using to compress the springs, I need to give a shout out to Marshall at Split Builds. If you haven't seen Split Builds, he has some really great Humvee content as well as some other fun stuff. Rather than using weight or trying to use spring clamps, this involves placing a wood post between the top of the Humvee and the underside of the ceiling above. In addition to the 4x4 post, I have a 2x12 at the top of the Humvee and a 2x12 at the ceiling to spread the load across several joists.
Sweet! Yes!
The rear was easier since I have a little storage platform that is relatively low and a little tougher at the front where the ceiling is high, but in both cases this worked really great. I was really surprised how easy it was to compress the springs. Thought it would be a lot tougher.
That was it. Ooh. It's so easy.
Notice that the lower shock mount bracket was left in until the upper shock bolt was removed and tension was removed from the coil, so that the shock acts as an added precaution to prevent the spring flying out. But that can be removed now. By the way, at the front, don't do this. The sway bar should come out before the upper shock bolt is removed, so that all of the tension is not placed on the sway bar, and then this happens. In order to get the differential output flange removed, we'll place one of the half shaft bolts back in order to limit the rotation of the flange. This is also a little easier to do while still on the vehicle. If I had been thinking, I would have also removed the input U-joint nut at this point, but didn't think of it. I don't have a hydraulic transmission jack, and I guess I could have used my floor jack, but this method of supporting the differentials while I remove the supports worked well. The diffs are actually not as heavy as they look, especially compared to the geared hubs, which are a little smaller in size but are much heavier. Okay, so I've got this down to pretty much just a very basic raw frame. I am going to break this down even further to take it down to every single piece. But before I do that, I want to talk a little bit more about what's happening here at the front differential. You may have remembered that I mentioned that the differential sits a little lower at the front than at the rear. And I was thinking about maybe trying to raise it in order to get ultimately the motor up above the bottom of the chassis to maintain that stock clearance. And along with that, what I was also considering was moving the differential to be centered at the front. It's centered in the rear, but at the front it's pushed about 3 inches to the driver's side, along with the engine being pushed over to the passenger side, which allows room for the drive shaft coming from the transfer case to plug into the differential at the front. And so I was thinking about sort of handling both of those things at once by centering it. And the reason for centering it, I don't need it to be centered. It works over here. I can have my gearbox and motor off center. The nice thing about centering it is it just gives me a little more room over here to work on the brakes. You have a lot of room on the passenger side, but it's really cramped on this side. So that would have been a nice little bonus just to center it for that reason, along with raising it in order to get the clearance. I was a little concerned about all the variables. So obviously where we end up at with each geared hub is the same as the rear. And if we raise and center the differential to that same point, then we basically have the same equation where I could just get rear half shafts to use at the front. Currently there's a longer half shaft at the passenger side and a shorter one at the driver's side. I would just get the two equal ones for the rear. So as long as I center this like the rear and put it at the same height off the ground as the rear, then it should all equate. And as far as what I was planning on using, so the front differential has a bracket on the bottom. And what I didn't realize actually is it's actually tilted a little bit, right? Because the drive shaft is coming in at an angle, so this leg is actually a little shorter than this leg, which is interesting. But I was actually thinking about getting a rear mount, which mounts at the top, not the bottom. Again, just trying to keep the equation the same. But the problem with all of that is that if you get the differential at the same height as the rear, the differential is going to conflict with this member. So I can get it close. I think it's about 1.5 inch difference, and I can only go about 3/4 of an inch. And you know, there's a little bit of play with those half shafts where it probably would work. But bottom line is, I think I'm just going to keep it simple. I don't think the clearance is a huge deal. I think that there might be other ways to solve that actually. The whole thing about centering is a nice to have, but not a need to have. So bottom line is, I think this is going to be a whole lot of work for a limited benefit, and so I'm not going to proceed with that. But just wanted to take you through the thinking there of what was possible, but ultimately I'm not going to move forward with that. One other thing you might have noticed in some of the videos is that this upper passenger side rear control arm is still on here. I'm having a hell of a time getting this bolt out. This bolt is loose, no problem here. This bolt, the nut is off, no problem getting the nut off. It actually came off pretty easy, but it appears that this bolt is like seized to the inside of the bushing, inside of this back control arm, upper control arm. So I've pounded on this thing. It's tons of penetrating oil in there. Right now you can see I got this clamp set up, seeing if I could just basically put enough pressure on it to get it out of there. There's a ton of pressure on here right now. That's not doing anything. So ultimately I may need to just cut this bolt out and then deal with it once I get the control arm out, deal with trying to get that thing out of there along with the bushing. Probably be cutting that out. For whatever reason, this one bolt for the upper control arm mounting bracket is different from all the others in that it is 2 bolts that thread into the frame from either side, rather than a through bolt. I'm thinking that this is to keep it more compact to the frame around where the steering gearbox mounts. You can see that when I remove the upper control arm mounting brackets that the camber shims fall out. These vary in size and number based on adjusting the camber of the wheels. I'll keep these together for each wheel to replace them, although my rear wheels had some positive camber, so I'll be removing some shims at the rear. Here's a better look at the shims. Next, I'll remove the chassis cross members that aren't being supported by the jack stands. And I'm removing the bolts that connect the bracket to the cross member first while it's still on the vehicle and a little easier to deal with, followed by the bolts to the main rails. Okay, before I continue taking this frame all the way down, just want to pause for a minute and check out what we have going here with this shimming out that I was talking about earlier. So you recall that I said that we were a little short in terms of the width between the frame rails to get the battery box in on the back. It sort of tapered in a little bit. And so I wanted to just check to make sure that the plan of shimming out was going to work. And what I have right now is I have it shimmed out with 2 pieces of 1/8. I tried 3/16 first, it was a little short. So what I'm doing here is I'm putting 2 pieces of 1/8 at each side. I just put the clamp on just to make sure it was compressed, to make sure I'm accurately seeing what I get. And if I show you the dimension here now, what you'll see is I'm right at 28 inches on the back. So if you line that up, you'll see it's right at 28 inches. So unfortunately I have to go with quarter. Obviously I won't use 2 1/8, I'll use a 1/4 inch plate at the back, and that should do what we need it to do. The last thing will be to remove the 2 cross members that are being supported by the jack stands, and I'm going to put it down at the floor for the final removal, but just loosening some of the bolts first. So my camera decided to crap out on me, but at this point the frame was light enough to lift off of the jack stands and place down at the floor so that the final removal could happen. And here is the final disassembly of all the parts, which will do it for this episode. Next time we will be cleaning and painting all of the fixed chassis components and getting that basic chassis back together again. See you next time.